Okay, so let's discuss our problem in our previous sheet work. So a long shunt DC compound generator delivers a 110 kilowatt at 220 volts. So if a RA is equal to 0.01 ohm, RSE or our series field winding is equal to 0.002 ohm, and shunt field has a resistance of 110 ohms. Calculate the value of the induced EMF. Okay, so first things first is of course to draw our circuit diagram. Okay, so we have positive, negative EG. Then our RA, which is equal to 0.01 ohm. Next is our RSE, which is equal to 0.02 ohm. Note that in this problem we don't have our brush drop. Okay, so therefore that would be neglected. So after this, next is we would draw our shunt, which is equal to 110 ohms. And then of course you have our terminals in which the load is connected. Now the load takes 110 kilowatt power, so therefore the power consumed by the load is equal to 110 kilowatt. And it was further mentioned that it has a terminal voltage of 220 volts. So the question is about the induced EMF, but how will we solve this? First things first is of course to know our IA, our RSH, or our ISH, and our I load. Okay, now it makes sense that our IA, or the currents that is in my generator circuit, is equal to the current in that is entering to my RSE in my EG, because it is connected in series with our RA. Right, now from here we can say that 220 volts is in parallel with our RSH, so therefore this is still, or our VSH is also equal to 220 volts. Now from this we can solve for our ISH and our IL. Or before that, let's take a KCL at node A. KCL at our node A. Now taking KCL at node A, you would notice that currents entering to the node is IA, currents going out to the node is ISH, and the currents going out to the node is also IL, which is also equal to 0. So from here we may solve for our IA, which is equal to ISH plus IL. Now after this, I can now solve for my IL and my ISH. How? Since my VSH or my RSH is in parallel with the load because it is a long shunt connected, so therefore I may say that my ISH is equal to my VSH all over my RSH. In this sense, this is equal to 220 volts divided by my RSH, which is equal to 110. So this is equal to 2 ampere. Next is equal to, next we would solve for our IL. So solving for our IL, okay, So in order to solve for our ILs, that we would consider the load, of course. So we all know that our P is equal to our IV, and the I that is entering to our load is our IL. So therefore we may say that our power, which is equal to 110 kilowatt, is equal to my I, which is equal to unknown, multiplied by my VL, okay, which is of course the voltage of the load, which is equal to 220 volts. So from here I will solve for my IL, which is equal to 110 times 10 raised to 3 divided by 220. So 110 times 10 raised to 3 divided by 220 is equal to 500 ampere. Knowing that my IL is equal to 500 ampere, so therefore I can substitute these values to this equation, okay, by substituting my ISH and my IL. So therefore we'll have 2 plus 500. So therefore my IA will be equal to 502 ampere. Now, so upon solving for my IA, the next thing to do to solve for our EMF is to take KVL at this mesh. So taking KVL at this mesh, we'll have negative EG plus the voltage in my RA, which is my VA, plus the voltage in my RSE, which is equal to my VSE, plus my voltage VSH. This is equal to 0. So therefore, what is my EG? EG is of course equal to VA plus VSE plus VSH. But what is my VA? Note that my VA is equal to my IA multiplied by my RA, and my IA is equal to 502 ampere, okay? So 502 ampere, so we'll have 502 multiplied by my RA, which is equal to 0.01, okay? Now it makes sense that we'll have a value equal to 502 multiplied by 0.01. This is equal to 5.02 volts, and my VSE is equal to 0.002 multiplied by 502, which is equal to 1.004 volts. Now from here, to solve for our EG, we would substitute our VSE, our VA, and our VSH. Take note that our VSH is equal to 220 volts, so therefore we'll have a value equal to our EG is equal to my VA, which is equal to 5.02, plus my VSE, which is equal to 1.004, plus our VSH, which is equal to 220 volts. Right. So from here we'll have a value equal to, so I would just add 5.02 plus 220, so we'll have a value equal to 226.024 volts. So that would be our EG, okay?